So I lifted the next few sections directly from my Math 114 class. I actually even deleted the word problems that were in the sections in my Math 114 class. So if you had me for Math 114, you've seen this identical material. And if you didn't have me for Math 114, this is kind of prerequisite knowledge. So I'm not going to lecture in the kind of detail I did when I introduced this in Math 114. I'll just kind of get us through the material as efficiently as I can. This is supposed to be complete review. The first 8 problems in section 2.2a, I made a 2.2a and a 2.2b because the section got too long, and I already had section 2.3 written. I didn't want to renumber everything. Anyways, the first 8 problems give me a line that has a couple points labeled on it, and they ask me to find the slope of the line that connects the slope of the line that's given, or the slope of the line that connects those 2 points. And we're supposed to remember that if I'm given 2 points on a line, I can find the slope of the line by using the formula m, which stands for slope, equals the y-coordinate of the second point, that's what y2 represents, minus y-coordinate of the first point, divided by the x-coordinate of the second point minus the x-coordinate of the first point. So slope of the line is y2 minus y1 divided by x2 minus x1. And in words, or at least all the words I can fit here, the slope of a line is equal to the y-coordinate of the second point minus the y-coordinate of the first point divided by the x-coordinate of the second point minus the x-coordinate of the first point. So you need to commit to which point you want to call the first point and which point you want to call the second point. It doesn't matter. So if I decided to call the first point the point 1, 3, and the second point 1, negative 5, negative 1, negative 5, can't really see that negative there. If I decided to do that and you decided to do this, call the first point negative 1, negative 5, and the second point 1, 3, our slopes aren't going to be different. And let me show you that. Let me do this first example. First example, slope's going to be y-coordinate of the second point, which is negative 5, minus y-coordinate of the first point, which is 3, divided by x-coordinate of the second point, which is negative 1, minus x-coordinate of the first point, which is 1. Now let me do this on my calculator, fancy. Parentheses for the numerator, negative on the bottom row of my calculator, 5, minus by the plus sign, 3, close my parentheses, and then instead of a fraction, a division sign, left parentheses, negative in the bottom row of my calculator, 1, minus by the plus sign, 1, close out my parentheses, hit equals. This tells me that the slope is 4. By hand, this would have been negative 8 over negative 2, which is 4. If you did the other version, you would do this for your slope. Y-coordinate of the second point, which is 3, minus y-coordinate of the first point, which is negative 5. Usually if I have two negative signs next to each other, I put the number in a parentheses. So y-coordinate first point, second point, minus y-coordinate of the first point, divided by x-coordinate of the second point minus x-coordinate of the first point. These have double negatives. If I'm doing them by hand, I would make this 3 plus 5 over 1 plus 1. That's going to be 8 over 2, and you get the same 4. So it doesn't matter the order that you subtract in, as long as it's second point minus first point, second point minus first point, y is in the numerator, x is in the denominator. When I looked at this line, I knew it was going to have a positive slope. Lines that move up from left to right have positive slopes. Lines that move down from left to right have negative slopes. So this first line for me and the first line for you had a positive slope. The next line we're going to deal with, it goes down as I move from left to right. It will have a negative slope. Lines that are horizontal have zero slopes. Lines that are vertical have undefined slopes. We'll get to all of these in the next few problems. So let me deal with number 4. I'm going to call the first point, and it doesn't matter. I'm going to call it 2, 0. I'm going to call the second point negative 4, 8. You don't need to take the time to do this is the first point, this is the second point. Your work could just be this. Take the slope, writing the letter M for slope, is the y coordinate of my second point, which is 8, minus the y coordinate of my first point, which is 0, divided by x coordinate of my second point minus x coordinate of my first point. Let me show you this on my calculator, because my calculator is not the best with fractions, but I can get a decimal answer, which this would come out on my calculator and turn it into a fraction. Good skill to have. So on my calculator, the numerator of the fraction needs to go in a parentheses, 8 minus 0, using the minus by the plus sign, divided by, the denominator needs to go in a parentheses. This negative here is the negative on the bottom row of the calculator. That minus sign is the minus by the plus sign. When I hit enter on this, I hate decimal answers generally. I wouldn't want that answer at all, especially a repeating decimal. To get your decimal answer turned into a fraction, hit the math button on your calculator, and then the enter in the bottom right-hand row of the calculator twice. So math, it's going to turn it into a fraction, enter once, enter twice. So for my answer, the slope is going to be negative 4/3. That negative sign could be written to the left of the fraction, could be written up in the numerator like I instinctively wrote it, and it could even be written down in the denominator, but that would be odd. But anytime I have a negative fraction, that negative is movable. As long as there isn't any adding or subtracting in the numerator or the denominator, the negative is completely movable. So this line had a negative slope because it moved down as I moved from left to right. 6 is a horizontal line, and horizontal lines have 0 slopes. I don't even need to do any algebra. I could just say the slope is 0, but let me do it. And I'm not going to be so formal about writing first point and second point. I'm going to call this my second point, this my first point. Write M equals, and then y coordinate of the second point, which is negative 4, minus y coordinate of the first point, which is negative 4. When I have a double negative, I put the number in the parentheses. And then in the denominator, x coordinate of the second point, which is 3, minus x coordinate of the first point, which is negative 5. Some double negatives I should make positive. I can rewrite the numerator as negative 4 plus 4. I can rewrite the denominator as 3 plus 5. In the numerator, the 4's are opposite. They combine to be 0. And in the denominator, 3 plus 5 is 8. Fractions with 0 in the numerator are equal to 0. Fractions with 0 in the denominator are undefined. So this is important. If you get a fraction with a 0 in the numerator, it's going to equal to 0. If you get a fraction with 0 in the denominator, it's going to be undefined. I can show you on my calculator. If I tried to do this, just the 0 over 8 part, tells me that 0. If I had a fraction like 5 over 0 with a 0 in the denominator, that's how it would look on my calculator. My calculator tells me I can't divide by 0. We'll just call that undefined. I'll hit the Go To button, 2, and just clear out my screen. Problem 8 and 7 give me vertical lines. vertical lines have undefined slope, so I don't even need to do the computation. If I recognized that this was a vertical line and I knew that vertical lines have undefined slope, that's what I would write, but it doesn't matter. I can do it without knowing that. Here's my first point. Here's my second point. Slope is y coordinate of the second point, -4, minus y coordinate of the first point, 3, divided by x coordinate of the second point, -6, minus x coordinate of the first point, -6. If you're not comfortable working with signed numbers in your head, use your calculator. I can do these just fine. Here the numbers in the numerator are both negative. I'll add them and keep them negative. In the denominator, I will make the double negative a positive. Now I'm adding opposites, and opposites add to be 0. I'm left with a fraction with 0 in the denominator. Fractions with 0 in the denominator are undefined, so I'm just going to say the slope is undefined for problem 8. So when we're dealing with equations of lines, there are two common equations, or the two most common equations are the slope-intercept form and the point-slope form. My nephew's taking Math 151 at GCC this semester. Didn't ask him not to take my class, but I've been tutoring the heck out of him. And my nephew loves this y equals mx plus b form. He ignores the other form. And that's fine. Well, I'll teach you both. And the slope-intercept form of a line is y equals mx plus b. And the m is the slope. The b is the y coordinate of the y-intercept. For example, if I give you the equation of the line, just in case this isn't big enough, y equals 3x plus 2. The slope is going to be 3, and the y part of the y-intercept is going to be 2. And we learned back in section 2.1 that y-intercepts have a 0 for x. So the slope is 3, the y-intercept is 2. Supposed to be able to graph this line. The way I did the first few problems will make me have to teach you something that you've likely forgotten, or maybe you didn't forget. But if I know any point, whether it's an intercept or not, and the slope of a line, I can graph the line. Well, let me show you. So since this equation was solved for y and it was in y equals mx plus b, or slope-intercept form, I know what the slope is, I know what the y-intercept is. In order to graph, I need a fraction version of the slope. The slope tells me how to move around from point to point. The slope is positive 3 over 1. The numerators are the y directions, which is up if it's positive, down if it's negative. The denominator is the x direction, right if it's positive, left if it's negative. What I'm going to do to graph this is I'm going to plot the point 0,2, which is the point that I got by inspection, and then I'm going to use the slope. From that point, I'm going to move up 3, which is the y direction. The y is the numerator for the slope. Positive is up, negative is down. And the x is the right direction for my slope. And positive is right, negative is left. From the point 0,2, I'm going to go up 1, 2, 3, and right 1. So to graph this, I would plot the point 0,2, which is just a point on the y-axis, and then I'm going to go use the slope, go from 0,2 to 0,3 to 0,4 to 0,5, and then right 1, that's actually going to be the point 1,5, and then connect those 2 points with a line. So if I know a point and a slope, I can graph, which means if I have an equation written in slope-intercept form, it's super easy to graph because I know what the slope is. It's just the number in front of the x. And I know what the y part of the y-intercept is. It's the number after the plus sign. This plus sign can also be a minus sign. We'll get to that in 2 seconds. So next 2 problems, 9 through 16, want me to sketch the graph of the line, state the value of the slope, and state what the y-intercept is. Say if there's no y-intercept. So for number 10, super easy. I'm going to state the value of the slope. the slope is m equals 2/3. This is in y equals mx plus b form, so the number in front of the x is the slope. This is in y equals mx plus b form, so the y part of the y-intercept is -1. So I stated the value of the slope, I stated the y-intercept. Now let me sketch a graph. How do I sketch a graph? I'm going to plot the point 0, -1. And then I'm going to go up 2 and right 3. The numerator is the y direction. If it's positive, it's up. If it's negative, it's down. The denominator is the x direction. My denominator is almost always positive, so I generally always go right. So I plot the point 0, -1. It's -1 on the y-axis. Go up 1, 2, go right 1, 2, 3, make a dot. If I'm not happy, I can do it again. Go up 1, 2, right 1, 2, 3. You can do that forever and ever and ever. Every time I go up 2 and right 3, I get another point that's on this line. Every time I would do that, I went up 2, right 1, 2, 3 again, and if I did the graph nicely, so if I went up 1, up 2, right 1, 2, 3, it's supposed to be over here more. My line is kind of failing on me. You can see it kind of turning up. Without a ruler, it gets kind of sketchy. But this is good enough. If you just do it once, plot the y-intercept, use the slope to get another point, connect them with something that resembles a line, even if it's not perfectly straight, good by me. So same instructions for number 12. The slope is negative, so I'm gonna have to go down. The slope for number 12 is going to be -1/4. The y part of the y-intercept is 3. The y-intercept written as a point is going to be the point 0, 3. And to graph this, I'm going to plot the point 0, 3. And I'm going to go down 1 and right 4. So plot 0, 3, go down 1, right 1, 2, 3, 4. Could do it again, but since I'm flying without a ruler, I probably shouldn't. Go down 1, right 1, 2, 3, 4. Try to make a line that actually goes through those points that's actually a line and not something that's, not really a line. So that seems reasonable enough. I probably should have written the point 0, 3 here. It would have been nice if I wrote what this point is, which apparently it's the point 4, 2, but not necessary. As long as you do the right movements, I'll be able to tell whether you're right or wrong. The next few problems are evil because they're missing a variable. I can't, this is not in slope-intercept form, I can't just plot, I can't just use the slope and the intercept to sketch a graph. Anytime an equation only has one variable, I've got to kind of logically force this out. And equations like the one we have here that only have an x graph to vertical lines. It's super easy to graph these. That's a big deal. And vertical lines, which are equations that only have an x, have undefined slope. I guess it should be ax, but just feel like and feels better now. So there's not a lot of algebra I'm going to wind up doing when we deal with lines that are missing one of the variables. Specifically, if I want to graph problem 14, x equal to 5, I'll find 5 on the x-axis because hence the x equal to 5. That's technically the point 50. And I'll draw a vertical line. That vertical line should look something like that. I should probably really get a ruler out. I think I have one close by. That would be a graph of this. And the reason we call it this line x equal 5, if you start looking at the points, here's the point 5, 3, here's the point 5, 7. The reason we call this line x equal to 5 is because every point on the graph has an x coordinate of 5. Here's the point 5, negative 6. So I sketched a graph. I'm supposed to say what the slope is and what the y-intercept is. Here, this is a vertical line, so the slope is undefined. This is a trick question when I go to find the y-intercept, because y-intercepts, as we learned in section 2.1, are points on the y-axis. If I look up and down the y-axis, there's no point on the y-axis, so this equation, this graph, doesn't have a y-intercept. Alrighty, so problem 16, I'm supposed to sketch a graph, say what the slope is, write what the y-intercept is, and some important things that we need to remember. Equations that only have a y graph to be horizontal lines. And equations that only have a y have zero slope, or a slope of 0. So let me graph this. To graph this, I'm going to find negative 4, this time on the y-axis. That's technically the point 0, negative 4. And I'm going to draw a horizontal line. A horizontal line would be parallel to the x-axis. If I look at some of the points on this line, here's the point 3, negative 4. Here's the point 6, negative 4. I should extend my line and put little arrows on it, signifying it doesn't end. Similarly, in this direction, I should probably put little arrows. Here's the point negative 3, negative 4. The reason why we call this the line y equal negative 4 is because every single point on the line has a y coordinate of negative 4. So I sketched my graph. That's part of what I needed to do. Also, what I'm supposed to do is say what the slope and what the y-intercept is. If I didn't remember that the slope of all horizontal lines is 0, I could find the slope. I could take any 2 points on the line and do the fraction. Y coordinate of whatever point I call the second point minus y coordinate of whatever point I call the first point, divided by x coordinate of the second point minus x coordinate of the first point, and do the math. I'm saving some time here, and you'd get 0. So if I didn't magically know that equations that only have a y have 0 slope, and I had 2 points on the line, I could figure out the slope. And the y-intercept, super easy to figure that out. Y-intercept are points on the y-axis. There's the point on the y-axis. That's the point 0, negative 4. The last line didn't have a y-intercept because it was vertical and it didn't cross the y-axis. But this line crosses the y-axis, so it has a y-intercept. Oh, 3 more problems that maybe are a little bit out of place. They kind of set us up more for section 2.3. But if I'm given a graph of a line and I know the y-intercept, I can easily find the equation of a line. I'm asked in problems 17 and 18 to write the equation of a line in slope-intercept form. So when I go to do problem 18, there's actually a part A, B, and a C, and I split them onto 3 pages. I'm asked to find an equation of a line in the form y equals mx plus b. Well, here's a line. It passes through the point 0, 2. The b is the y-coordinate of where the graph crosses the y-axis. So I look at my y-axis, I see the point 0, 2. That means the b is 2. To find the m for my equation, I'm going to just do the algebra. Take the y-coordinate of what I call the second point, which is going to be 2. minus the y coordinate of what I call the first point, which is going to be 0. Form that in the numerator of a fraction. And then in the denominator, take the x coordinate of what I call the second point minus the x coordinate of what I call the first point. This is going to give me 2 over 0 plus 4, which is 2 over 4. And that gives me m equal to 1/2. I have everything I need to get the equation of this line because I know what the m is and I know what the b is. Simply now, all I'm going to do is take the numbers that I've inspected to find or calculated to find and plug them into the y equals mx plus b formula. So the equation for this line is going to be y equals to 1/2 x plus 2. This strategy only works if the line is slanted. It doesn't work for horizontal lines, it doesn't work for vertical lines, and it only works if you know the y-intercept. If you don't know what the y-intercept is, then you don't know what the b is, then it's way more complicated. We'll do that kind of problem in a few sections. Next few problems want me to find equations of horizontal lines or vertical lines. Problem 18b wants me to find the equation of the line that I drew here. And of course, this is a horizontal line. And I should know that the equation of any horizontal line will only have a y. Equations of vertical lines only have an x. So immediately, since I'm asked to find the equation and it's not a slanted line, I can't use the y equals mx plus b strategy, I need to use my logic. It's super easy. It's a horizontal line, the equation only has a y, and the points are screaming out to me to tell me what to use. Each point has a y of -5, so this must have an equation of y equals -5. One more and then we'll do a part 2 to this video. Problem 18c asks me to find an equation of a vertical line. And I have to know that equations of vertical lines I can't really get by algebra. Equations of vertical lines only have an x. So I know my answer to find the equation of that line has to be x equal to some number. And again, the number is supposed to be obvious because each point has the same x coordinate of -5. So the equation of the line in 18c is x equal to -5. We're at 28 minutes. The next part's going to be really short, but I don't want the videos to drag on much more than 30 minutes. So we will do a part 2 for this section in a few minutes here.